Now, last time I saw you, I did mention that we're not talking about a probability of 90% that the population proportion or whatever it is, whatever your level is, lies within that interval. And so that is just really reiterated here. So you've got it in black and white. And so we are, and there's the reason behind that. You can see how it talks about the idea that the population parameter, in this case it's the proportion, is constant. That doesn't change. So it's either in the interval or it's not. And so you can't say there's a 90% chance that it's going to be in the interval. So don't think of it like that. What we need to think about is that idea that you've got, if we have to do a series of samples, in this case I've talked 90% confidence level, so you've got 90% of those intervals will capture that true population proportion. And then I found another definition at some point that kind of gives that same idea. So when you're asked to describe, you know, what does it mean? Well, this is kind of a good example, that you've got the idea that many, whatever it is, that percentage captures that population, that percentage of intervals will capture that population proportion in this case. All right, we also talked about the width decreases as the sample size increases. We're more confident because you've got more people. Logically, it kind of makes sense. You've got more people in the sample, so you would expect a little bit less variation. And that's logically, and then formally we can talk about that because the standard deviation decreases as n increases, because you're dividing by n. That will reduce the standard deviation, and obviously if the standard deviation increases, the width will increase. So that is just the converse statement there. And I think I was, one of them is about the confidence level and one is about the sample size. So either or. But what's more important, or what's important, is that you'll be asked to explain often these sorts of things. So you just need to get that in your head, that the standard deviation, because you might be asked about the standard deviation as well. So how does the standard deviation change, and how does that affect your confidence interval, the width of the interval in particular? So there's some statements there to help you with that. The wide confidence interval means that you've got a sample size that's too small, perhaps. That could be something that comes out. So remember, we are checking the parameters for that. We've got to make sure that n is large enough. And you've got the whole reason and the whole assumption that we're making for us to calculate these confidence intervals is also we've got to justify the n times p and the n times 1 take p as well. Otherwise, we don't have a data that is normally, or a distribution that is approximately normally distributed. So there is a website that might be helpful. So at some point you can have a look through Khan Academy that just gives you a bit of a different or slightly different explanation. I have stolen a couple of questions here coming up though from there that also might be helpful. So here's a scenario. I'll let you read it. Is the first one true? Do we agree with that? Yes, no, maybe? Yes? Why? Yeah, so we talked about this idea of 90% capturing the true population proportion, and 18 out of 20 is that 90% of intervals. So yeah, that one is true. What about B? No, definitely not true. What about C? That is true. It's kind of just a slightly different version of A. No, not true. That's not how we interpret it. And what about E? Yeah. Yeah. So 90% confident. We're not talking about a probability there. Just be wary. That's not a probability. That there's a little bit of a dubious statement. But yeah, we've got to have a certain level of confidence. But it's not, just make sure you're not referring that to a probability, because we either capture that true proportion or we don't. So this statement here can be a bit dubious, but some resources will say that that is true. For us, what's more important? The most important interpretation is this one, you know, like A and C.
It says 90%.
Yeah, okay, sure. All right, so here is an exam question. Finally, you get to see what we're looking for. Don't worry about A part 3. We haven't quite covered that, but I just wanted to kind of give you an idea. So I'm going to give you a chance to try it. See how you go. Question, what is the... Hang on a minute. All right, so on the E activity list, you can see there the ones that relate to this topic is really sample N for CI, Z score for CI, and CI for proportion. So in part A, part 2, we need to find the 95% confidence interval. So I'm just going to show you how to use that E activity. It's the CI for proportion. So if you just tap in that. Now notice you'll see lots of stuff here. If this goes haywire, what you need to do is in your E activity list, just get out of there, go new, just so it clears all the lists, and then go back in and open it. And generally that fixes any issues. But it's got this whole thing. What we've got to do is go back up to the top. And if you're not sure, you forget, you can just press that little I button next to the CI for proportion, and it'll give you some information to help you. So I'll just tap that so you can see what I mean by that. It just reminds you. So there's 3 numbers we've got to put in. N, capital N is the number of successes, lowercase n is the sample size, and C is the confidence level. So if we go back to this, as I was suggesting, we need to do for this question, we need to overwrite that 10 with 56, number of successes. Let me do it, please. And then we overwrite that 50 with 250, and 0.95 is okay because that's what we want. And then we just hit execute. I think execute should work. Doesn't want to do it for me. No, it's telling me there's something not right. What have I done wrong here? Oh, it's 50. Didn't like my 2. Okay. I'm sure I put that 2 in there. Okay. So let's try it again. Well, that's good. It tells you there's something wrong. So notice it does a whole heap of things. So it's pretty good in that way. And this is an advantage of using the E activity because it gives you stuff. Let's see what it gives you. Firstly, it gives you, what's that 0.224?
That's the
yeah, that's your P8. That's your proportion just as a decimal. What's this one? 0.026368, etc. Yeah, that's your standard deviation. These are all the things you write down, right, as you're working. And then what's the next one? 1.96. That's your Z score associated for this confidence level. And then you've got your interval. So you should be writing those things down as part of your working so that you can get marks. Now, this particular question was worth 3 marks. That's probably a bit generous. So to just write an interval is not enough. You've got to actually give some stuff. So you've got the P hat that you're using, of course. You've got to make sure you put in your Z score. And seeing as we've got it here, we might as well put the standard deviation as well. Now that is SE stands for standard error. We'll talk about margin of error next time I see you, but you can put that in as well. And that'll do. And then you can give your interval. So at least you will get some marks, because for a 3-mark question, answer only is not enough. There's got to be some kind of working, unless you actually set up that equation, which is not particularly nice, you know, that big inequality equation.
I'm sorry, I didn't see about which.
I'll come and show you. And part 3, don't worry about, and answer part B, I'll give you. So we would need to get another sample and then make a decision. If that was out as well, then what are the chances of 5%? You know, 2 already out of 2. But we don't know for sure. Next one, the mark allocation. So here, so the marks, you have to say bias with a reason, and then second mark is the first mark, and second mark is the second reason. You've got to give 2 reasons there. The 2 reasons are fairly obvious. And then similarly with the next one.
It's unbiased.
It's unbiased. It's better. That is, the question's not biased.
But not everyone would own a phone. But if you don't own a phone, you're going to get a tablet.
Yeah, so you've only got mobile phone users here. So there could be an issue. Yeah, not everyone will pick up. I know my husband doesn't answer the call if he doesn't recognise the number. I can tell you that right now. So yeah, you're not capturing.
So that's biased.
So even though the question itself is not biased, it's a better question. There is bias in the fact that they're using mobile phone users, and people might just hang up as well. So you're not capturing enough of the population.
What was the second one?
So you've got only mobile phone users. You're not capturing people who don't have mobile phones. People will hang up. So you're not capturing, a true representative of the population, that kind of thing. They're the suggestions made by the examiners there.
If you said not biased, and then
No, it's because the question's not biased, but the scenario is.
so there's always
So it has to be a bias.
there's a right and wrong in these types of questions.
Most of the time. It does depend on how the question, sometimes the wording might be a little bit ambiguous and then they might suggest alternative responses. But most of the time, you'll be able to determine yes or no, one or the other, bias or not. So there's always a little bit of ambiguity, and they're pretty flexible with the reasoning as long as it kind of makes sense and you're not just, whatever you do, don't hedge your bets. Don't say, oh, it's biased, but then it's not biased. Don't do that because they won't accept that. Yeah, definitive, be strong with your answer. Next part. So I know this is binomial, talks about success or failure. It also talks about the number of tablets as opposed to proportion. So we go with binomial. And we want more than 4, so we've got that means binomial is a discrete distribution, so 5 or more. And according to my calculations, that's what we're looking for. So what is the distribution? You don't just write binomial, it's 2 marks. So you've got to give the parameters. So make sure you do that.
Oh. I did the standard deviation. I misread the question. What do you mean by that?
N and P for binomial. That's what we define. We define the binomial distribution. If it was normal, you would give the mean and the standard deviation.
But that's all you need. The X is the binomial.
Yeah, that's okay. If you say that's fine. That's
Or
fine.
you could say it's binomial.
Yeah, or you could use words. It's a binomial distribution with n equal 200, p equal 0.01.
Yeah, you did it. In the next.
All right, so here's where we start talking confidence intervals. Again, 3 marks. So where do the 3 marks go? So according to the WAIS, the first mark is for the sample proportion. Have we done this one? So the sample proportion is 4 on 200. The second mark goes for the standard error. So in other words, the standard deviation. I always like to write the z-score as well, but the standard error is also important. So if we go back to this E activity, let's put in the info. 4, so annoying when it does this, 4 out of 200, 0.95 is still okay, and hit execute, and there we have the info we want. So standard error 0.0099 effectively, and then your interval 0.0006. It's set to 4 decimal places, so make sure you give it to 4 decimal places. In the marking key, didn't mention anything about 4 decimal places, but sometimes there is a mark allocated for that. Not always. So not in this case, but sometimes there is. So the mark went for this, and it's only 1 mark for the interval. What about part E? Are we done? What do I know? Here, that first line is important because we can make that we can justify the approximation because of those 3 things being satisfied. And so by the central limit theorem, we can make the assumption that we have got this approximately normal distribution. Make sure, as I said, you give your 2 parameters, the mean and the standard deviation. So if it's binomial, the parameters are n and p. If it's normal, the parameters are mean and standard deviation. So remember, it's sample proportion, so the standard deviation is the p hat or the p times 1 take p on n. So the next one's a little bit different. What's the probability that the sample proportion of large mangoes is less than 0.58? So your population proportion we know is 0.6. We know that we have a sampling distribution that approximates the normal. We have the parameters, so stick those parameters in and make a calculation for a probability based on your 0.58 or less. That's what we're trying to determine here. That sample proportion is less than 0.58 based on this. Yes, so on your calculator, just go back to, well, while I'm in the activity, we can do it here as a normal CDF. Probability is what we're trying to find. Lower bound will be negative infinity. Obviously, you can do this in the upper bound is 0.58. Standard deviation is is whatever that was. Now that standard deviation is 0.02191, I think, and the mean is 0.6. And then we solve. So that's doing it as an E activity, but you can obviously do it in the inbuilt calculator routine as well. All right, is it time? Keep going, please. Finish off. I want you to finish off. Oh, it's just that question. So please finish off that question and we'll move on tomorrow. Thanks, everyone.